So in the last discussion, we highlighted the spatial information representation. We differentiated between map and sketch, and then we defined and highlighted salient types and characteristics of maps. We also explained the key elements of maps, where we put before you the significance of scale and projections, etc. Especially in the context of real world spatial information, that is, the three dimensional feature onto the transformation into two-dimensional flat plane, the significance of map projection is very critical and complex. So, spatial representation in a map involves determining the geographic locations of the features on the earth. Now, moving ahead today, we look into another very important element of spatial information, the georeferencing. The idea of depicting the earth on a flat map is easy to imagine and even simple to understand. But the actual process of a map projection is really a very complex task. This is complex because Earth is also quite complex in terms of its aerial dimension, not only the dimension but also the undulations which prevail over the Earth's surface. Moreover, the Earth is a complex three-dimensional object with physical dimensions including height, depth, width, mass, and density, etc. They all are important physical characteristic. And important fact is that these physical characteristics, it's not straight, but they are curvilinear surfaces. This curvilinear property adds complexity to depict Earth to a flat surface. Due to Earth's curvilinear surface, map projection always hold a degree of distortion, which we discussed in detail previously. In this part, we will discuss about the concepts involved in transforming three-dimensional Earth into two-dimensional maps on paper. So georeferencing is the process in which we relate, synchronize the Earth phenomena to correspond map phenomena. So georeferencing is the process of aligning geographic data to a known coordinate system. This helps us to view, query, and analyze with other spatial data, especially from the same location, of the same location. So the phenomena may be changing, the attributes may be changing, but all of them, they belong to the same spatial location. It involves shifting, rotating, scaling, skewing, and in some cases, warping, rubber sheeting, or ortho rectifying the data. Now, all of them, they are very easily can be done in digital mode. So that is why spatial data in digital mode has great relevance in modern day representation of spatial phenomena. And georeferencing is used to bind the digital spatial database that represents a geographic space to a spatial reference system. Thus, this way we are locating the digital data in the real world. This image depicts how ground realities exist, and when we digitally represent them in spatial format, it is shown in different layers. And all these layers have common coordinates and common referencing. For example, if you take this example, this image you take into consideration from top to bottom, you can find that all of these phenomena, they are stitched to the ground. So the bottom one is the real picture, real image of the ground realities. But if we if we take out only the trees, then it is in the first layer. If we take out only the buildings, then it is in the second layer. And if we also bring in only the streets, then it is represented in third layer. And the last layer, the fourth layer, the bottom layer, it is the ground realities, which has all of them, they all these phenomena, they are stitched together. So this is how we are georeferencing, we are aligning all these phenomena with a specific coordinate system. The layers have common coordinates and common referencing, but each layer represents the same spatial unit but different phenomena of the same region, or in other words, different attributes of the same geographic space. As I have explained in my previous slide, that all of them they are separated into one layer. Each layer is representing one phenomena, but actually in reality all of them they are stitched together, which is the integrated data. So this means georeferencing is done with identifying common points, the locations which we call as ground control points. So the georeferencing is done by associating features on the map image with real world X and Y coordinates. Here in digital mode, the software can progressively warp the map image so it fits to other spatial data sets. So that is how the georeferencing is being done. Now, so here you see that how we are taking all the layers in terms we are stitching them with latitude and longitudes that we have explained in our previous discussion, where latitudes are horizontal lines and longitudes are vertical lines over the Earth's surface. And this is how we are doing the mapping, plucking out some phenomena of our interest, which are representing different phenomena of the same area. So this means georeferencing is done with the identifying common points, locations, which as I am saying as called as the GCPs. And here we are associating features on the map image with real world X and Y coordinates. Here in digital mode, the software can progressively warp the map images so it fits to other spatial data sets. Again, the same argument is explained in a different way, where we are representing the real world, where land use, elevation, parcel, and also the transportation network, etc. All of them, they are being plucked out in one layer, in different layers. So that is how, and all of them, they are stitched with the coordinates, and this is the process which is known as the georeferencing. So this image is an example of a settlement. Now suppose if this image is required to bring into spatial information system environment, I mean if we want to georeference it, we need some ground control points which can be easily located. Now these ground control points need to be very specific and easily located on the image or the map. So now this is one very basic exercise. If you have to georeference this specific image, you examine it carefully and think of few appropriate GCPs which you feel would be easy to provide coordinates of them, and then we may georeference it. So which GCPs would be more appropriate? You just look into the image and then you will have an idea. You see, we have ground control points for each location of this image, but those which have specific intersections, they are easy to locate. So in this image, if we have to georeference it, there can be some intersections of, say, the roads, or some intersections, very specific points of certain buildings, structure, etc., which are easily identifiable, located, and these locations, these intersections can be offered as the GCPs for georeferencing this specific image. Now here you can see that in this image you can see that Here one can understand that few very prominent features like building corners or street junctions or any prominent intersection which we have the coordinates, the GCPs, and some points on digital map or image of the same location. And then we assign the map GCPs the coordinate from the real world. This way we georeference the map, which is actually aligning the map locations with ground coordinates. In other words, assigning and matching the same coordinates on both the maps and the real world. So this is what is known as georeferencing. Now you have the background information of it, where we talked about the coordinate system, where we have Cartesian method or the geographical location method, where the latitude and longitudes can be the best example of offering the georeferencing to any map. So here, as I am saying, that GCPs would be representing specific coordinates, geographic coordinates, in terms of latitude and longitude. And when we identify these intersections, then we will put these coordinates to these intersections, and that way we will bring the non-spatial data. This image will correspond to the ground coordinates, and this is how we georeference any map or any image. So I can say that georeferencing is basically a process which locates the digital data in the real world. Georeferencing in spatial information science is a process that involves associating a digital database. Thus, georeferencing represents a geographic space with a spatial reference system that again we have discussed earlier, the different kind of reference system. It's a type of coordinate transformation that binds a digital spatial information, usually a scanned map or an image, to a spatial reference system, and that way we georeference the maps. The process involves identifying a series of ground control points known as XY coordinates. X denotes in Cartesian the horizontal way, and Y the vertical way. But in geographic coordinate system, X denotes the latitude and Y denotes the longitude. So that this XY coordinates, they link locations on the datasets with locations in spatially referenced data. So the basic steps involved for georeferencing: add the spatial dataset, that is to align with our projected data. So there would be one data set which is already aligned, which is already georeferenced, or we are aware of the coordinates of that particular geographic space of which we are drawing some GCPs. And the common points, in one data set we will have the known coordinates, and the map which has to be georeferenced according to the another map of which the coordinates are known, they would be used to georeference the another map. So the use of control points which connect to our spatial information to the known positions in the map and ensure the control points are free from the errors. Now you see, this is also very interesting, that when we are georeferencing, if the original map has some errors, any kind of error, if this error continues and if this error loaded data is transferred to or georeferenced to new data set, then the error may multiply or it may also increase. So it is very essential that the control points should be without any error. And this way broadly the georeferencing is done, and spatial information, the maps, are aligned with ground coordinates. So the control points are locations that can be accurately identified on the spatial data sets, which we relates with the real world coordinates. The control points are used in conjunction with the transformation to shift and warp the spatial datasets from its existing location to the spatially correct location. So now you realize and understand the significance of georeferencing for spatial information science. When we use digital data, so let me further extend the importance of georeferencing, as georeferencing is crucial for also integrating spatial data available in formats that cannot be immediately integrated with other spatial data. It is also a necessary step in the digitizing process, because that would be the beginning of creating our own data set from the real world. So for that purpose, when we are creating our own data set, first we have to georeference it. First we have to assign coordinate to that geographic space of which we are drawing some spatial information for our convenience. So digitizing in GIS is the process of tracing in a geographically correct way the information from real world information to the image or maps, etc. Actually, this is what the basic objective, basic significance of spatial information, that the ground realities we are assigning coordinates, we are making it spatial information, and that way we are preparing maps in digital format. So digitizing in spatial information science is the process of tracing the geographically correct way the information. And georeferencing is the process involves identifying a series of ground control points, and these control points can be accurately identified on the spatial data set in the real world coordinates. So the ground control points, known as XY coordinates, that link locations on the spatial data sets with locations in the spatially referenced data. And georeferencing is crucial for integrating geographic data available in different formats that can be immediately integrated with other spatial information science data. Now, if I can signify the importance of georeferencing, I would say that georeferencing is crucial for several reasons. For example, first can be said as for mapping and analysis. It allows for accurate spatial referencing and analysis. As I am saying again and again, that the power of spatial information is, the utility of spatial information is that we are depicting the ground realities onto a flat plane in a map. And here, in this case, we are representing it digitally. So that is what is the utility of georeferencing, to represent the real world information in the form of mapping. And further, when we process these map, we may analyze and we can draw out some inferences out of it. Now these inferences would be very important and critical. Why? Because some of the inferences, some of the realities may not be easily identifiable, but in the form of map, in the form of pictorial representation of ground realities, we may identify some important features of the ground realities. So georeferencing connects the information to a map, displaying it in relation to its position in the real world. Now, there is another dimension which we can add, especially in terms of digital spatial information, because the information can be updated with time. So these spatial information, when we georeference it, it also has time dimension added to it. So it becomes time sensitive data. It can contain very essential information produced at different point in time. That is particularly useful when we analyze the changes in the features or the phenomena under study over a period of time. So this way, the georeference data, we can produce the change detection in the phenomena. So I was saying about mapping and the analysis part. If we add the time dimension into our spatial information, very easily we can have different time period information, and we can analyze and understand the changes which are happening in our information, spatial information. In summary, I would say georeferencing is a critical way to manage and analyze spatial data or information by adding the coordinates to the real world. Now, over the Earth's surface, we know the location of any geographic space, but how we can relate it with the ground coordinates, that process is the georeferencing, and that is why I am saying it is very critical in representing the spatial information. There is another important feature of georeferencing can be the data integration, where different maps may use different types of spatial information, but all of them they belong to one spatial location. So georeferencing tool contains methods to combine and overlay these spatial information, and if there is no error in the original spatial data, then there would be very less or minimum distortions, and that helps us to analyze and examine the changes or the transformation which are happening over the time or within the geographic space. And we can also relate different phenomena of that geographic space by adding just this space dimension into our spatial information. The applications are enormous, and georeferencing is key for a spatial information science to analyze and manage different type of data acquired from different sources. This is also very important and advantage in spatial information, that in this digital mode we can accommodate, we can bring in all formats into one common layer, and this is again I would say the power of spatial information to bring different kind of information, adding the spatial dimension to it, georeferencing it, assigning coordinates to any spatial information, and that way it adds value to our understanding about the ground phenomena. So georeferencing means where geographic location is the element that distinguishes spatial data with non-spatial data. The spatial data are those where the coordinates are known to us. Non-spatial data are those which are devoid of any coordinates or spatial information, where we cannot directly relate with the geographic space. If the data is not related to specific location, that is non-spatial data. For example, like a garage have 10 vehicles in its premises. This is a non-spatial information. But if premises of the garage spatial location is linked to the number of vehicles, it might become the spatial information. This linking of spatial location can be done through georeferencing. So georeferencing is the method for specifying location on the Earth's surface for spatial data in a map. The primary requirement of georeferencing is that it should be unique. Not only unique, but it should stay constant through time. And there is only one location associated with the given georeference. Now, a very interesting example is the settlement, the city of Hyderabad. But we all know that one Hyderabad is in India, and another Hyderabad also exists in Pakistan. So this way there is uniqueness of the name is compromised. It can create confusion if the name changes. For example, if you look into the early maps of India, the name was Madras. Now it has changed to Chennai. So the same location, but we know that Madras is now known as Chennai. But if this information is in digital mode, then we need to rectify it. And that is why I am saying that georeferencing needs to be unique, and also it should remain constant through time. because we have talked about the time dimension into our spatial information. And when we are georeferencing, we are assigning coordinates. These coordinates need to be linked to any geographic space, the name of which, if it is in digital mode, needs to be unique. Otherwise, there would be some kind of conflict in identifying the geographic space only by the name of name, only through the name of that particular location. But yes, when we assign the coordinates, we can easily know that this is the specific geographic space which is under the investigation. So these are some examples of commonly used georeferencing. Here you need to understand basic characteristic of georeferencing. As I was mentioning, the uniqueness. Not only the uniqueness, but also its consistency and also the resolution. Now, resolution is the perfectness of that particular georeferencing system. Now, I am offering here many examples, and each one of them, they are a type of georeferencing. But you need to understand that which are the georeferencing type which are consistent with time, which are unique, and the digital mode of spatial information actually adopt those georeferencing system where the characteristic of georeferencing has uniqueness, where the resolution is perfect, and they are consistent in dealing with that geographic space. Now you look into the examples. As I have mentioned about Hyderabad, the place name varies. So we cannot take all the time the place name as one of the georeferencing. In day-to-day life, most of the time we refer to any spatial location with the place name. But in digital mode, when we are representing spatial information in digital mode, it may not work perfectly. Another can be the postal address. Now, this postal address again is unique, but this postal address does confined to any country or any state. As we move away from the country or the state, the uniqueness of postal address do not remain consistent. So that is also something which we cannot take all the time as a type of georeferencing for spatial information. Another, you can take the postal code. Again, the uniqueness only belong to the country. Different countries have different method of representation for postal code. So again, the uniqueness do not exist. And again, I would say that this may not work for spatial information. Similar is the telephone code. Now, earlier when we had landline, each city had, in our country, had specific telephone code. Now we have moved to mobile connection. So here, some digits are assigned to certain space provider, service provider. But again, I would say that these do vary. So we may not take it as latitude as consistent georeferencing system for representing the spatial information. Whereas latitude and longitude, I would say that they are unique, and the resolution is also very fine if we move ahead with the digits after the decimal. So when we deal with the decimals within the coordinates, the resolution, the spatial resolution becomes infinitely fine. Another is the UTM, which if you recall in our previous discussion, we have said that this is one important coordinate system where the areal expanse is 6 degree on latitude and 6 degree to longitude. This is also infinitely fine spatial resolution, and that we use for georeferencing.